Hello, I'm Jan Vykopal from Masaryk University, Czech Republic. I'm presenting a paper introducing scalable learning environments for teaching cybersecurity hands-on. In cybersecurity hands-on classes, learners interact with networked computer hosts. Their interaction is driven by a learning environment with or without assistance of instructor. Each student works with an own instance of the lab environment. Hands-on classes enable gaining cybersecurity skills, but they do not scale. Why? Their preparation requires a substantial effort from instructor. There might be delivery issues, especially in large classes, and providing personalized feedback and analyzing learning gains of students is difficult. We therefore focus on enabling scalable teaching of classes using interactive learning environments. We identified three building blocks of cybersecurity classes. The first block is Sandbox, an isolated environment for practicing cybersecurity skills. The second is class delivery method, computer-assisted instruction that employs the sandbox. And the last block is learning analytics, components for analyzing students' interaction in the sandbox and the class delivery. The first block is represented by sandbox definition, which describes structure of the network, hosts, and their configuration. Topology definition can be described in machine-readable formats such as YAML. On the right, you can see visualization of a topology network with two hosts, two networks, and two routers. And on the left is their description in a machine-readable format. Provisioning definition describes configuration changes at the host in the topology. We use base boxes, which are minimal installation of particular operating system, such as Linux or Windows, and all data and application are provisioned at these base boxes. Provisioning definition is in fact input for software configuration management system, such as Ansible in our case. Our approach provides more flexibility in preparing a sandbox. Instructors can reuse the definition for other classes. Here you can see an example of provisioning definition with two tasks aimed at a host name server. First task, install Apache Web Server and prerequisites, and the second task, copy application to the web server root. Next building block is training definition, machine-readable description of consecutive tasks that have to be solved by each student. Here is an example of one training phase with assignment, worked out solution, correct answer, and optional hints, all in JSON format. The last building block is Learning Analytics Stack, a mechanism of processing events from environment. Events capture interaction of the students with sandbox and training. Events are machine-readable strings in syslog format. They are forwarded to central storage, which process them and present to instructors and students. The central storage uses the ELK stack, Elasticsearch, Logstash, and Kibana. Using these events, instructors can see which commands were typed into terminal or whether students submitted wrong answers, correct answers, and so on. On the left, you can see example of one event capturing command typed in the Linux terminal at the machine in the sandbox. And on the right side, you can see example of event capturing submitting incorrect answer in one training phase. Based on these building blocks, we developed two learning environments: Kaipo CyberRange, Kaipo's CRP in short, and Cyber Sandbox Creator, CSC in short. Kaipo CRP is cloud-based platform for running multiple classes in parallel or classes which require sandboxes with many hosts. CSC is a lightweight distributed lab environment that can be deployed at a single computer or laptop. Both environments use the same formats for definitions and same formats for events processed by learning analytics stacks. Instructors can choose the environment that suits better their needs. If you are interested in the architecture of both environments, please take a look at our paper. What are the use cases? First is formative assessment in large classes. Students exercise their skills with various tools, and using CSC, every student can deploy the sandbox locally on their own computer. That means this deployment is suitable in low-stakes contexts where students can see what is inside, what is provisioned at their host. The advantage is that the local deployment doesn't need any cloud resources. However, teachers need to be prepared to provide detailed instructions or troubleshoot the setup at students' hosts. The distinct use case is summative assessment, where we need to hide the sandbox definition from students. Kaipo's CRP provides access to the sandbox deployed in a cloud, and students connect only to the machines in the sandbox, but they can't see their definitions. What is more, teachers can control the visibility of hosts in the sandbox topology and hide some hosts. To sum it up, we provide scalable and reusable building blocks for cybersecurity hands-on classes. We exploit these blocks for developing two learning environments: cloud-based Kaipo CyberRange platform and host-based Cyber Sandbox Creator. Open definitions and formats enable educators to edit and reuse the existing environments without much additional effort. The environments have been used in teaching at multiple institutions in Europe since 2019, and both environments have been released as open source software. If you are interested, you can download source code right now from our GitLab repositories or read the documentation or study architecture in more detail in our paper. If you are interested in our other projects in cybersecurity education, take a look at our website or follow our Twitter accounts. Thank you for listening.